So in Lesson 8.3 special right triangles, we have two types of triangles that have these special ratios that we don't have to use Pythagorean theorem every time. We can use the pattern. So a 45-45-90 triangle and then a 30-60-90 triangle. So with a 45-45, that is an isosceles right triangle. So these sides are the same. These angles are both 45, and it has this ratio of these sides being x, x, and then x radical 2 for the hypotenuse. So it follows that same pattern of whatever the side is, it's the side radical 2 for the hypotenuse. So for example, on letter A here, it's a 45-90, and this would be 45. This leg is 9, which means this leg is 9. And then the hypotenuse, x, would have to be 9 radical 2. So go ahead, and if you want to try this one, it's kind of challenging, but I think you can do it. Try it and see how you do. So we need to basically add a radical 2 next to it. Well, what happens is if this is 6 radical 2 is our side, and then we take another radical 2 times it, we have radical 2 times radical 2, which is the square root of 4, which is 2, so it's 6 times 2, which is 12. So we would have a side here of 12. So looking at this one, working backwards, if the hypotenuse is 8, what were the legs? So we know that 8 has to equal a radical 2. Our side A times a radical 2. So let's go ahead and solve for a by dividing by radical 2. And that gives us a is equal to 8 over radical 2. Now we can't have a radical in the denominator spot. So what we have to do is what's called rationalize. We have to take the top and the bottom times that radical. So when we do that, we wind up with 8 radical 2 over, and then this gives us the square root of 4, which is 2. And then lastly, we can take 8 divided by 2, since they're not under the radical, and that gives me 4 radical 2. So each of these sides was a 4 radical 2. All right, we have a quilting example here. And it looks like it wants us to find the dimensions of each triangle. Each of these is an isosceles right triangle. So if this whole side is 3, then that would mean that this part would be 1.5, this would be 1.5, and then we can find our hypotenuse by doing our 1.5 times radical 2. And you can have it like this, but we really don't necessarily want the decimal, so this is really 3 halves. So you could have 3 radical 2 over 2. We need our radical 2 in there. But 3 halves is our 1.5, and then we put our radical 2 there. So that is going to be our hypotenuse, and then our sides are going to be 1.5. So this by 1.5 by 1.5. So those are dimensions of each triangle. All right, so down here, if you want to go ahead and try some of these on your own, just some more review with practicing our 45-45 ratio, and go ahead and check when you're ready. First one we can just look at and say, oh, I just have to multiply it by radical 2 to get the hypotenuse. This one you have to work backwards. 14 is equal to x times radical 2. And then we want to divide both sides by radical 2 and then do our rationalizing like we did up above. So it's 14 over radical 2, and then take and rationalize top and bottom times radical 2. And then we wind up simplifying lastly the 14 divided by 2. So it's 7 square root 2 for x. And then this one, we're going to take and just multiply it by a radical 2, which there already is one. So it is 11, the square root of 4, which is 11 times 2, or 22 for x. So now we're going to take a look at our 30-60-90 relationship that we have for a right triangle when we have a 30-degree angle, a 60-degree angle, and a 90-degree angle. So it really depends on what's across from each other here for the relationship. So this side, if this side was side S for across from the 30, we would double it for the hypotenuse, and then we would take it times radical 3 for the side across from the 60. So the kind of middle side, if we want to call it, kind of short, long, middle. So in order, I always take the short and double it for the longest side. So we're going to take our 4 radical 3 over 3 and double it. So y is going to be equal to 2 times our 4 radical 3 over 3, which means we're just going to double the 4. We don't double everything. So 8 radical 3 over 3 is doubling that. And then for our x, what we end up doing is we end up multiplying it by a radical 3. So x is going to equal 4 radical 3 over 3 times a radical 3. So we already have a radical 3. So when we do that, that gets us 4 times the square root of 9, which is 4 times 3, and then we divide it by 3. So 12 divided by 3 is 4. So x is 4, and then there's our y. So let's go ahead and, if you want to try a couple more with me, go for it. Short side, we're going to double it for our hypotenuse. So x is going to equal 14. And then we're going to take our short side, multiply it times a radical 3. And it's 7 radical 3 then for our long leg. So now we have our long leg. We need to work backwards to get our short side. Remember, we multiplied it by radical 3. So 12 is actually equal to x times radical 3. And then we're going to work backwards. So dividing by a radical, we know we can't have a radical in the denominator spot, so we have to do our rationalizing. Take the top and the bottom times radical 3. So 12 radical 3 over the square root of 9, which is 3. 12 divided by 3, we can reduce that to 4 square root 3. So that's our short side, and then we want to double it to get our hypotenuse y. So y is equal to, when we double this, 8 radical 3. So again, try that last one if you want to on your own. Otherwise, you can check when you're ready here. 10 radical 3, so we're going to undo the radical 3 with it to get our short segment. It's just this first part there, so 10. And then we want to double it. So y is 20. Double our short side to get the hypotenuse.